Check. Hey, we're going to start in about 2 minutes.
All right, good afternoon, everybody. We're going to go ahead and get started at Don's instruction. Good morning, everybody. We're going to go ahead and get started with the talks because Don wants us to get through them before people have to go back to work. So I'm going to be talking about JIB today. In the ThoughtWorks radar, JIB is in the trial phase. So it's this one right here. And it is a Google project that big picture goal that JIB is trying to accomplish is allowing Java developers to make Docker containers out of their Java projects without knowing anything about Docker. So they want the build process to include, like if you're Maven or Gradle or whatever, they've got plugins that they've built that allow you to take your Java app, package it up in a Docker image and publish it to whatever registry you want without the developer having to have Docker installed on their machine or without having the developer have to write a Docker file and manage layering of the image for optimizing Docker image sizes and stuff like that. So that's the big picture of what they're doing. And so they've got 3 goals stated right here. Number 1, they want it to be fast. Part of the way that they do that is by layering the images where the dependencies are at one layer, the static resources are at another layer, and the classes are at the top layer. So most of your changes while you're developing are likely at the class layer, and so what gets communicated about the difference between the images is rather small. It's not like you're building a jar file, putting the jar file in a Docker image, and that whole thing gets sent as a package in a layer. So they're trying to make it fast. They are also trying to make these images reproducible, meaning if you have the same source code, it should generate the same Docker build. They do that by deleting a lot of the stuff that would change between builds, like timestamps and everything. So if we get to the demo, you're going to see that the Docker container timestamp, it was always built 49 years ago. And for being daemonless, you don't have to have Docker running on your machine to do this. I do have Docker running on my machine, but they say you don't have to. I trust them. And you can push it to whatever registry you use just with the plugin. So, any questions on like the big picture of what's happening? I put together a small example, but that's the overview. Okay. So, I wanted to show you, here it is. I know it's small, sorry, but all we're doing is saying, hey, all I did was take an existing Java project, this is the EG employee evals app, and added a plugin for the Jib Maven plugin, and told it which registry. I'm running a local registry because I didn't want to mess with accidental whatever happening during my presentation. So that's all that I did. And then we will run a couple of commands. So we don't have any containers, and there's no existing images, and the registry, just want to show you that I didn't seed this with anything first. The local registry currently does not have any repositories in it. So then we'll just build the project. With the Jib build, standard Maven project going. The first time you build it, it does take a little bit longer to download the base image. The base image that is used by default is the Google distrolist Java image, but you are allowed to specify whatever base image you want to use. Now it's there, and if we do, sorry. Now if we look at the contents of the registry, well, it's got the project, and I've got a command in here. I can download the Docker thing and build it, but it's not that impressive because the app doesn't actually work. I couldn't get the login to work. So, but that's what the project is doing. I didn't write a Docker file or anything. I just told it, build me a Docker image. It built one and put it in the registry. There is another build goal where you can just, if you have a Docker daemon running locally, then you can have it published directly to your Docker daemon. For instance, if you're doing development and you just want to keep updating the image locally until you know what you want to push it to a remote repository. That's Jib. Yeah, there's a Gradle plugin as well as a Maven plugin.
All right. Working on showing you Nest.js here. Funny thing about it is that before last year's Tech Radar, I had just found out about Nest.js, and so I sent it into ThoughtWorks right before, but of course it was too close to when they were releasing. So I was really happy to see when they did have it as a part of it this year. It's in the assess category, and I thought it was interesting that it scored a 91 specifically, which means it barely made it out of the hold category, or it's closer to hold than trial, I guess. So I was going to do a quick summary about it. These are my notes, and then hopefully mow it a tiny bit. So yeah, what is it? Let me just pull up its homepage here. It looks like this, but it is what they call a Node.js framework that uses TypeScript and helps you build enterprise-grade, efficient, and scalable Node.js applications. I thought one of the paragraphs about their philosophy on their GitHub page was the most interesting. But basically it says that it aims to provide an application architecture out of the box which allows for effortless creation of highly testable, scalable, loosely coupled, and easily maintainable applications. Sounds great, right? Yeah, so let me just, I was going to just highlight like some general things, like it has 22,000 on GitHub, it's got 130 contributors, but if you look at that, the vast majority are by this guy, Kamil Mislowick, no idea how to pronounce that, who is the creator, and then there's, there's a handful of other people, but the most anyone else has 57 commits. And I thought it was interesting that he has his own little site here with his business or whatever, where he's paired up with this other guy who is part of the Angular Universal team. And so we'll see why that's interesting here in a second. But let's see. So back to the GitHub page for a second. One of the nice things that they do have is this samples directory here, where they've got a whole bunch of different things they've done with it, basically. So they've got like a general app here, just shows like hello world, and then they've got, if you want to use it with Mongoose or SQL, whatever type ORM, or how you use Swagger with it, GraphQL, all kinds of different, auth example, using Fastify instead of Express. So yeah, they've got a nice little catalog of samples here. Oh yeah, the other thing I was going to highlight were the companies that use it in prod. Did I ever put that in here? Yeah. So supposedly these are the companies that are using it in prod. Some of the things that got my eye were like Roche, Adidas, who knows to what extent they're using it, but they're supposedly using it. And then there's a whole big list at the bottom of people that didn't get their logo up there. So it is used in production by some people, which is always comforting. All right, so I was going to get into the constructs that it's built with, I guess you could say. So one thing that is interesting is that it's made to closely resemble how Angular is constructed. And that can be nice because Angular, well, there's a lot of people that know Angular, so maybe if you want a backend that you already have some familiarity with out of the box, maybe you can use Nest.js. Then you've got TypeScript, full stack basically, which has some advantages. But it uses terminology from Angular, which I thought was interesting. So you've got controllers, providers, modules, pipes, guards, interceptors. But the interesting thing is that I only like some of them or half of them, maybe not that many of them actually mean things that are that similar. I guess like the idea is some carryover, but I mean, they're not. It's not like a pipe. You know, an Angular pipe is used for transforming something in a view. It's used like in a view, and then like in Nest.js, it was used for something that where you're transforming something, but in a completely different scenario. So it can be a little confusing, but I was going to go through quickly each thing, I guess you could say, construct. So controllers, which is the page I'm on here. This is an example of a controller that does barely anything, but I guess I was going to start with modules. So a module is like the organizing structure. It's at the bigger level. So you always have a root module, and that's the starting point that Nest uses to build their application graph. And then Nest is huge on decorators, which are, well, in this example, you've got like these @get, @controller, you know, anything that starts with basically. And you can use them to decorate classes and methods and all kinds of different things, parameters even. Let's see. So basically a module uses a @module decorator, which you supply a bunch of different things in there, just like you do in Angular with like imports, providers, exports, and whatnot. And so then that's how Nest knows how to resolve all the different relationships between modules, and you know what their dependencies are on other modules and what they include. You know what controllers and what components they include. And Nest encourages you to employ multiple modules, each encapsulating a closely related set of capabilities. So I don't think I'm going to get through all this if I go through all of this. So controllers handle incoming requests and return responses to the client, which is what you see here with this cat controller. Services are, click on that, are dependency injected into controllers, which is similar to Angular, and they're mostly used for data storage and retrieval. This is an example here with a service that's not hooked up to a database. They just have a list of cats, and they're pushing to it and finding specific ones or all of them. And then I've got middleware, which is basically a function that's called before a route handler kicks in. And the example they give is a logger middleware. It basically executes some code, can make changes to the request or response objects. It can end the request response cycle or call the next piece of middleware in the stack. Pipes are used to transform data or validate data. And like the next two constructs I'll be talking about, guards and interceptors, they can be applied at the controller scope, at the method scope, or globally applied to everything. And so at the controller level, you can apply a pipe. I'm not going to scroll down to where they do it, but basically you can do, if you wanted to apply a pipe to a specific method or endpoint of a controller, then you do this, you put this above the method, use pipes, validation pipe, and then your validation pipe gets applied just to that endpoint. Guards are, you can determine whether a given request is allowed to be handled by this route handler at all. And so for the example they give is like a roles guard. If I can find that. Roles guard. There we go. And you can put that on like a controller, or like I said, you can put it on a specific method in the controller or globally. But they apply, for instance, right here, then a specific method in the controller can say like, hey, you have to have admin role to use this endpoint or whatever. And then interceptors, I'm not going to click on the page, but basically you can buy extra logic before and after method execution. Examples they gave were transforming a result or transforming an exception that's thrown by that method. We'd apply that by putting this above the controller, this decorator, use interceptor, logging interceptor, or whatever. I thought it was funny that they use logging for two different constructs. But all right, I probably am over on my time a little bit. I was going to generate a new Nest project and run it. I will quickly attempt that, but we'll see how far I get. So I already installed it globally, and then I was going to do Nest new test project. This is the project name. And that'll be running while I quickly give my opinions. Maybe I won't run them without me doing things. So what I found was, despite being decent at Angular, I wasn't able to ramp up as quickly as I would like. I like the idea of Nest, and I plan to look into it more. I actually wanted to try to write the voting apps backend in Nest just as an exercise and see what happens, but I didn't get as far as I would have liked before this talk. I would say that similar to Angular, I felt like the learning curve was fairly steep, even though I was coming from Angular. Documentation, they have a lot of examples, but overall I thought it was a little sparse. I think it's because it's not as popular as stuff that's been out longer, like Express and whatnot. But they did have, samples, and they cover like the easy cases, but not always the hard cases. I did enjoy being able to just use TypeScript through full stack, so that was nice. One thing I thought of as maybe a con is because they're imitating the Angular structure. If Angular changes how it does something, for instance, a couple versions ago, they went from most of the time using the providers part of a module to declare a service. They started doing provided in and declaring services that way, then you didn't have to include them in a module. Nest still does them the old way, and probably will keep doing them that way. And so it was like, well, it was cool that it matched, but now it doesn't match how Angular does things in that area. So, and then another thing that I don't know if it's a pro or a con, but seems like you kind of need a solid understanding of what a TypeScript decorator does or can do, because they use them on everything. I think that's pretty common in the back-end world. I'm not a back-end developer, so yeah. So the project generated, so if I go over and attempt to open it up, I can show it to you. Am I at like 10 minutes now, not 5? Okay. I'll not do my last one, then I'll just quickly show you what it generated. Ooh, that's small. 4K screen. So if you look at the package JSON, you've got all your Nest dependencies and whatnot here. TypeScript stuff down here. I thought interesting under the scripts section, you've got start dev, which if you kick that off, I can't remember if I have anything else running at the moment. I think not. So if I kick off that, I need if you kick that off, it'll quickly compile everything, and then as you go in and edit things, so like let's say I come in and change my app service to say hello EG, and then and then save it, then detects the save and immediately rebuilds without having to do a whole lot at all, and the save is live. If I go to localhost 3000, and it says hello EG. So it's pretty basic, but it gives you a module which has one controller and one service. The controller looks like this. It's just a get, and it makes a call to this app service that says get hello, and then that just returns a string. So really simple. In my example, when I was working in the voting app, I was able to add, let me kill that other one real fast. I was able to add in Swagger stuff, which was nice, but I haven't gotten real far, so I didn't get Swagger working exactly how I'd like, but it looks like this. I've only written this little configuration endpoint. If I did the Swagger stuff properly, then you would be able to click here and see like what a configuration had, and maybe have like a description and that kind of thing, and see, you know, possible responses that would come back and whatever. All right, I better move on to my other topic, or I will never get to it. Let me exit this stuff. On Windows, no, oh well. So, when I was working on the Sweet Spot app, I was in charge of setting up the pipeline for building, deploying, you know, creating the repo, etc. So I created it in Bitbucket, and then I learned a lot about Bitbucket pipelines and deployments, and so I just wanted to share that quickly. So the first thing I wanted to touch on was the deployments section of a Bitbucket repo, which is fairly new. I think it's new in the last year or something, maybe. And it's kind of nice because it allows you to track what is in each of your environments. We only have a dev and prod environments on this project. But if you click on, you know, this, you can see, if it loads, each of the last commits to production. And so if you click on a specific one here, or actually I'm going to click on this one, then in here you can see you know, what commits are included in this this push to prod, an entire diff of the code as it was before and after, any PRs that were part of this merge to prod, and then all the issues from Jira that were included, that were closed by this. So it's kind of nice to be able to track that and find that in convenient place. So in order to set that up, which is what I'm going to show you partially, you go over here to settings. You got to be an admin, I would think. And then over here in deployments is where that would get set up. So they have test environments, staging environments, production environments. So I put dev under test, which doesn't make a lot of sense, but there's nowhere else to put it. I'll come back to this part. Quickly, I'm going to go over to settings. So this is where you say that you want to use Bitbucket pipelines. And what Bitbucket pipelines is basically you can have it build your stuff, deploy your stuff when you push to a branch, or all different types of triggers. But here's what it looks like. You can keep track of all the times the pipeline is run and view it here, and it says, is it successful? You can click in and see each step, like what it did, and all the stuff that happened under that command and whatever. So the main thing I'm going to show is what I learned about the Bitbucket pipelines file itself, and that will tie into what we just saw. So on the right here, this is the pipelines file as it were before I did some refactoring. And it was during the refactoring stage that I learned a lot about all of this. So as you can see, you've got a whole bunch of redundant steps. So let me just break this down. So basically, you've got this image at the top. So that's a Docker image. You can use any Docker image from Docker Hub to any public image from Docker Hub, and you're going to be performing all of your builds and deployments on top of that. So under default, this is what will happen if none of the other cases apply. So like under branches, we've got just development and master. And so if anything is pushed to the repo that's not on the development or master branch, it would hit this default pipeline, which just builds lints and tests the front end. And then if you look at what happens under development branch, you can see there's a lot of redundant steps here, but then there are some new ones as well. And then the same thing under master. You'll have to trust me on that. And so what I wanted to do was get rid of this redundancy. And so if you look on the left here, we've now got a steps section, or a definition section with steps that we define, whereas over here we just had pipelines. So if you look at the steps, what I basically was able to do is pull out the redundant stuff and define a step. For this one, I called it build lint test bundle, because that's what it does. And then anywhere you want to use a step, so the other step I created was deploy. Those are the only two steps. Anywhere you want to use a step, you refer to it like this, with the star. So definition is the ampersand, and then referring to that is the star down here. So you can see for all pull requests, I wanted to just build lint, test, and bundle and do nothing else. For the develop branch, I wanted to build, lint, test, and bundle, but then I also wanted to deploy. But I wanted to deploy to the development environment, whereas down here in the master branch, I wanted to deploy to the production environment. And so that's what this here syntax does, allows you to, it says, hey, I'm going to use the deploy step, but I'm going to override some of the, what would you call those? Some of the variables or whatnot. So like, for instance, if you go look at our deploy step here, it has a name defined that just says deploy to AWS Elastic Beanstalk. Well, down here, I overrode the name and said I want to deploy to AWS development, but in prod I said I want to deploy to AWS production. I also, another thing I wanted to touch on is this property right here, the deployment. That is what ties it back to those deployments that I showed at the beginning. So we've got our development and our production, and so that name has to match. And so when you do that, then that's when it starts tracking it over there in the UI that we were looking at. And so for development, we build, lint, test, bundle, and then if you look at the bottom of that step, there's an artifacts area. And the only thing we put in there is dis.zip. Artifacts just means, hey, I have one thing, or I think you can do more than one thing, from this step that I want to expose for use in the next step. Or I don't know if it has to be the next step necessarily, but, and so then our deploy portion here refers to that dis.zip right here, and it's able to do so because I exposed it in the artifacts area of this previous step. And then one other thing, another difference between dev and prod is that dev I wanted to automatically deploy every time that the dev branch changed, but for prod I wanted that deployment when the master branch changed to be manual, and you can do that right here with trigger manual. And then when that happens, you can go over to your pipelines, and I think if we look at master and click on this, well, I guess you'll just have to trust me because I must be doing something wrong to get to it. But basically, there will be a button right here that will say deploy. And so it'll build and whatnot, but then it won't do the deploy step until you press the button. And that's done using that manual trigger. And then one other thing I was going to touch on is that you can use these repo environment variables, which is what I'm doing here. So if you go back to settings and you look at repo variables, you can define repository-wide variables here. So if it's the same for all the environments, you could define them here. But if you go over to your deployments area and click into those, you can define them per environment as well. So I had the Beanstalk environment name be Sweet Spot Dev here because that's what it's called. It wouldn't work if I didn't have the name right. And then down here it's Sweet Spot Prod. And then you refer to those with the $sign in here. Oh, and another thing to note is that you can, when you define them, you can mark them as secured, and then they won't like show up in your logs and stuff like that. It's a safer way. I think that's about it. Probably forgot something, but we'll call that done. I forgot to mention that if you want to put any permissions around that manual trigger step, then you have to have Bitbucket Premium, which costs double per user that's in your Bitbucket environment. So, yeah, that was a big problem.
Right. Cool. Awesome. Yes, I don't change my background. Yeah, I use the same one. It's from a game called Child of Light, which I don't play anymore. Not anymore, at least. Anyway, that's it. So I'll be talking about Micronaut, and it's currently on trial, and it's a JVM framework. All right, cool. See if I can switch back here. Hopefully it works. No? Trying to get my presentation to go to right screen. Come on, presentation. I think that's what I do. Hold on a second. Present. Yeah. Where's my notes? I need it. What? Why is it so hard? See, yeah, okay, here we go. Got this, guys. All right, sorry about that. So yeah, I'll be talking about Micronaut, and Micronaut is a JVM full stack framework. So who here are Java developers? Who here has used Spring? Right, so the reason why the first thing I put here is because anytime someone says, let's use a full stack framework, it's going to be besides Spring because it's so common. At least for me, I have not worked on any project that doesn't use Spring heavily. I know there are some projects in MISO, for example, that don't use Spring, but it's like 1 out of 26 or something like that. It's like most of the applications that we have uses Spring. So therefore, if I actually propose this, it will be like, how does it stack up with Spring? So that's the reason why I put this slide. And what I noticed with Micronaut is it's very similar to Spring as far as its programming model. And it seems to be that it also has feature parity with Spring as well. So it includes features like external configuration, auto configuration is included, yes, HTTP routing, security, cloud-native features, and like a bunch of extra libraries for integrating with third-party systems. But I think if we actually like want to like compare it more, I think depending on your requirements for your project, you probably want to dig deeper than that. What's interesting though is that when they created this framework, according to their website, they actually hired a bunch of Pivotal developers to actually create this framework, and Pivotal is the people who actually created Spring. So it kind of makes sense that their APIs are very similar. And most of their features, if you read their documentation, will actually say it is inspired by Spring or Grails. Which makes sense because later on they have cross compatibility with Spring. What's interesting about that is it actually makes adoption to Micronaut easy for introducing this to a company that's already like heavily using Spring, because it will kind of help with like the management being scared that we're pivoting too much. They actually have a library specifically for integration with Spring, and what it does is that it provides a few Spring annotation processors, so that all of the Spring annotations can be used with Micronaut, and you can actually run a Spring application according to how they advertise this. You can actually run a Spring application as a Micronaut application, which means you get all the advantages that you get from Micronaut. So advantages. So why are we talking about Micronaut in the first place? What's funny is that they have this like slogan right at the top of their, call it natively cloud native. And I think all it means is that when they designed Micronaut, they had cloud as a target environment for where you actually deploy Micronaut. And another thing also is that all of their cloud native features are part of their core library. I think that's why they advertise themselves such. And another thing also is that they advertise themselves to have fast startup times and lower memory consumption. So I think that has something to do with how they do their dependency injection feature, as well like their AOP feature, which is common in Spring. Spring heavily uses that feature as part of its like core functionality, and because they don't use reflection or dependency injection and AOP, they use ahead of time compilation. What that means is that all of the drawbacks with reflection, where you store all the metadata in memory, and as well as like scanning for injection points or all the different dynamic reflected like methods and whatnot and fields, don't need to happen during runtime. So, which means that you avoid this problem where as your application grows, you get more and more memory consumption and and slower like scanning, right? And another thing also is that it's compatible with Graal very much because of ahead of time compilation. And Tyler will be doing Graal. All right. They also advertise themselves as polyglot, which is interesting because all of the JVM language that they actually advertise is just JVM languages. So it's like Java, Kotlin, and Groovy, and those are the three things. What's interesting, though, is that Groovy is a dynamic language, but they were able to kind of make it work with Micronaut anyway through AST transformation. So that I thought was interesting. All right, so someone told me that they don't trust speakers that don't say disadvantages about the product, so that's why the slide is here. That's my slide right there. So Micronaut, as I said, it does ahead-of-time compilation, right? So it needs to spend more time during compile. So that's one disadvantage. Another thing is that when it does the AOP advise, it creates subclass of that class that it's applying advice to. And what that means is that it actually extends the class and then overrides methods when it injects all the advice. And the problem with that is that for language like Kotlin, it's final by default. So it won't just work out of the box. And fortunately, there's a workaround for that where if you have an all open plugin, it makes all classes that are annotated with an AOP annotation will become open. So that's how they get around that. And I was looking at I was trying to figure out how it stacks up with Spring, and I found a blog, and what I found is that there are certain integrations with third-party solutions that Micronaut doesn't have as many options. What's good, though, is that they kind of target all of the popular third-party solutions, so they kind of prioritize that, and it probably just has something to do with like their they did their official release last year, so they're somewhat new, right, compared to Spring. These are the different integrations that I found to be they have less options. So I'll cover Graal real quick. So what is Graal? What do you get with Graal? And the biggest thing probably is the faster start time, like even faster than if you were just using Micronaut. And I can show you like data that I when I was testing this. And so why is startup important? When you're dealing with like in the cloud, where, for example, if you're doing auto scaling, because of traffic spikes, if your applications can't start up fast enough, that means that by the time your applications are up and running, the traffic spike might be gone, so it's useless, right? So you need to be able to react quickly enough, and so that's why startup times is really important. It also has lower resource consumption with Graal, and I can show you like the comparisons between the different deployments that I've done. And then it has smaller images when you're using multi-stage builds, and the reason is like because it's pre-compiled with all the JVM, like you don't actually have to have the JVM running. You can actually compile it and then trash all of the ones that you use for all the files that you use to compile and rebuild in a new image, and you get like a smaller Docker image. So what's interesting is that even though Micronaut is very compatible with Graal, the libraries that Micronaut uses and maybe libraries that you would use is still using reflection. So it might not mean that whatever Micronaut application that you actually develop will be immediately compatible with Graal. But you can still manually create like these reflection configuration files that you'll then use to give hints to the compiler when you build the Graal image. Another thing to note is that I saw this on their website that the version 19 of Graal is considered as production release, but the native, the support for native image build is actually still considered as experimental. And I actually have an experience with this, and I can show that to you guys later. This is just like what when I was playing around, this is like not a benchmark. I just ran it, and then so I can show you guys. Right here. So the top, I think I copied and pasted this wrong. So yeah, I copied and pasted that wrong. Here, I'll show it to you guys actually. That's too bad. So anyway, I might not have. You know what? Oh, sorry. I'll have this running while. Yeah, I do have it. Of course, when you're like doing like research on a new framework, you have to write a hello world application. I think that's required. You can see right there, startup time is 4.3 seconds. So you've probably seen faster startup times than that. So this is a Micronaut. And then if you look at the Graal one, oh, ignore that. That didn't happen. I actually, that's one of the ones I wanted to show you guys later on. But you can see right there, startup time is 67 milliseconds. It's pretty quick, compared to the other one. And then I was playing around with Spring Boot too, just to do a comparison. It's 12 seconds. So it is faster. Yeah, these are all like Hello World apps. They're not like one-to-one. Like they're not exactly the same, so it's kind of arbitrary. Exactly. That's a good point. Like we're dealing with like reflection versus non-reflection, right? So when you add more and more classes into Spring, they actually get slower and slower. What's interesting though, and you guys probably already guessed this, but when I added CPU, it got like so much faster, right? You can see that it's like cut in half, and which makes sense. And that just means that Spring actually is multi-threading startup, right? But what's the problem with that? That even if you have that kind of option, when you have a cluster with multiple applications running, when you start them all up at the same time, that means all of them are going to try to use as much CPU as possible, and they're all going to compete for that, so you're still going to have problems anyway. This is the memory consumption for all three. You notice there, Graal is like so much lower, and Micronaut is still lower than Spring Boot. All right. So, and then I posted it here because people ask, like, what's using this thing? And this is from their website. So Minecraft uses this, so that's like game over. Like everyone's gonna use this, right? So, yeah. 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 All right. So, so I showed you guys something. So what's interesting though is that when I built the native image, so I have this app, this Hello World that I was telling you guys about. If you notice, there's a field here, host name. This is annotated so they actually injects that value into, on startup, you actually pull from the environment and add the host name right here. What's interesting is that this works. Like, so if I go to like, where's my Hello World example? is it this one? So right there, right? So this works, right? So this is the Micronaut running in like just plain. But if I switch this to the Graal VM one, I have it in this port. It throws an error. It's exactly the same. This is this source code here with 2 different Docker files. What's interesting is that this field kind of just disappeared. And I think that might be a bug, or I built it wrong. But I thought that was interesting. It didn't just work. So there's still a problem there somehow. At least it was not foolproof. And if you notice, like that log that was shown earlier, I think this one. Yeah. See, it says no such field host name. So I thought that was that's interesting. That I don't know what I did wrong, but I wanted to show that to you. So there's another disadvantage there. It didn't just work. Another thing that I thought was interesting as a feature is that they have a feature for Spring has this thing. I think it's like Spring IO. It basically it allows you to create the app scaffolding like for you. So this one right here. So I'm just going to illustrate this real quick. It takes like maybe 10 seconds. It will create the skeleton of the app for you, and then that way you don't have to deal with all the different dependencies. Because remember I was telling you about like Kotlin has is final by default, and you have to add like a bunch of like plugins. So you don't have to do that if you use that generator, because it does that all for you. Which is like Spring also has similar type features, but it's where's the Gradle? Is that the one? No, that's not it. So like all of these will be done for you, and they also have features for like create a new controller or create a new scheduled task or something like that. That's also available. All right, I think I'm done. So, all right, you guys, all right.
How about now? All right, I might be a little more of a palate cleanser after that. But oops. I guess that's going to hang out down there for now. All right. Are we going? I'm in. Did I break it in a different spot? Okay, here we go. Switch it. Wrong end. I thought I had the right one, but no. Not so much luck. Here's the adapter. He's special. Okay, we're working. We're live. All right, I'm doing data build DBT, data building tool. It is on assess. I'm not sure which category. I don't have that all set up. So yeah, like I said, this will be a little bit more of a palate cleanser. So this is essentially, for those of us who are familiar with Liquibase, this is essentially Liquibase for a data warehouse. So it's basically just a transform layer and an ELT, transform after load kind of thing. And this is just an aside, but ELT is like the new big data gatekeeping word. It's like one of these code words, like, oh, you're not big data enough if you say ETL. So it's all this idea, like, we're just going to get it into the data warehouse, and then we'll deliver it from there. And so this is especially with like the best-in-class data warehouses. So this is stuff like Redshift, Snowflake, BigQuery, and others. Looker falls in this category as well, that are capable of all the transformations. In the past, we've had a separate transformation layer after that. Once it all goes into the data warehouse, it goes in through transformation layer and then gets to the end users who end up using it. But this is all, because it's so scalable and so performant now with these big, massive data warehouses, it can all happen in database. So basically, DBT, just like Liquibase, takes code, compiles SQL, and runs it against the database, a command line tool applying essentially DevOps tools to a data analytics pipeline. And so this is the same thing with Liquibase. Like, you guys who are developers are like, this is so basic and like basic building blocks of software development, but to data people, this is like revolutionary, being able to put in some of these things and have source control and have automated testing. Like, all these things are just revolutionary. So just bear that in mind as we go through here. But you had me at SQL. Literally everything is a simple SQL select statement. And like Liquibase wraps all these SQLs in XML, the DBT combines it with Jinja, which is a Python templating language to allow things to do like implement control structures like if or for loops within the SQL. You can abstract SQL snippets as reusable macros. These are essentially the equivalent of functions that you can use. You can change the project build of the SQL statements based on the target. So say you're targeting dev, it'll run a certain SQL statement, or if you're actually running against prod, you'll run a different SQL statement. So things like that. And then you execute. So when you use dbt run in the command line, it'll actually materialize it in the data warehouse. Default is a view, but you can do things. You can create a table. An ephemeral is essentially a temp table. An incremental is a table that will continue to insert rows rather than just being a static table as well. So dbt addresses a couple of the challenges that people are facing with pushing the analysis layer into the actual database or the data warehouse. One of those is testing. Data models are only useful if they're correct, and manual testing and data work is particularly error-prone. Multiple models are tested against one another. The underlying data may change. So dbt starts to introduce some automated testing. Very bare bones. It's mostly checking the result set that you're generating after running this test. These are things, so they have schema tests and custom data tests. So schema tests would be things like, are you returning any nulls at all? Or are you returning within a set of accepted values? Custom data would be like, if you exceed 0.5% of null values, it fails the test. Things like that. So this is just a way to introduce some of those basic building blocks. Documentation. Data transparency is becoming more and more of an end business user requirement, and pushing more transformation into the data warehouse or just turns the data warehouse more of a black box. So with a modular approach like dbt does, like most software development and source control, it's easy to communicate to the stakeholders where the data comes from, how it maps to business knowledge, and how it changes at each step of the way to where it gets to end business users, analysts that are using it at the end of the process. The benefits are literally the laundry list of everything we do in software development. Version control, code review, modularity, sandboxing, environments, package management, automated testing, and documentation. Like, this is it. This is what analysts and data folks are just kind of going gaga over right now with this type of tool, because they haven't had these types of things that they've been able to trust in the past. And this works so closely with SQL that it brings a lot of those benefits. For EG use, we don't currently do this type of data work, but if and when we do, this type of tool is exactly the kind of thing we want to have in our toolbox. It very much fits our style. It's open source with a reasonable community. I didn't pull up all the GitHub pages and everything like that. It brings in version control. Adopting this can improve the client's ability to maintain long-term. It turns their actual analysts into producers rather than just being consumers of IT. It allows them to produce an artifact that's in source control that they can then build off of and rebuild as they pass around their models. And it allows easier communication with end business users to provide that transparency. So this is kind of, I know I went through that crazy fast, but this is basically mostly taken from the link. You can find it in the Tech Radar. Or that, yeah. Any questions? Great. Thanks, guys.
There we go. My computer never works with this, so we'll see. Good company. All right, let's see. Yeah, except I need Android Studio, so. I know. Didn't have time for that. I mean, my computer recognized it. I can unplug and replug. Sometimes that just works. I can power down and turn it back on again.
So while he's doing that, we've got 3 technologies in adopt that are unclaimed. So there's opportunity, React style guidist, with a React thing, ESLint, probably a linter for ES extra script. Joel will take those two. And commitism, I have no idea what that is. So, commitism, it's like commit, like, says Sam Miller. Somebody give this guy.
Hey, look at that. You just have to look up here. We good? We're almost good. Sorry to cause problems. Yeah, I was actually going to ask you that. Yeah. All right, so I am talking about Flutter. And so Flutter is a cross-platform framework that enables you to write native mobile apps. So it's in the trial portion of this. I'm actually surprised to see it there. I believe that it should be teetering on adopt just because there's like tons of usage out there now, and like even just like searching a lot of this stuff, Googling it and trying to figure out, there's like a huge community and a lot of support, and a lot of companies actually have apps in production using Flutter. I mean, I think the only reason why it's in trial is just because cross-platform, there's always very unique use cases for it, and it's not always the right thing to use. So let's do here. All right, so real fast, just so what is Flutter? Flutter is Google's UI toolkit for building beautiful natively compiled applications for mobile web and desktop from a single code base. That is their description of it. why would we use Flutter? So we already know that there are a lot of like frameworks and things out there, like Xamarin and whatever else that is out there. Progressive web apps. So why Flutter? Fast development, from my experience, it has a very, very good developer experience. Like that's what everybody talks about. Like when they use Flutter, everyone says the dev experience is just so awesome with all the integrations that they have. So when you're building Flutter or Dart, Flutter applications with Dart, you can use any IntelliJ product, Android Studio, and it has full VS Code support as well. There's a great plugin that they built. And it works really, really well. So yeah, they say obviously it's made by devs, but they say it's made by devs for devs, and they're really focusing on that, the whole experience as a whole. Fully customizable widgets to build native interfaces. The UI stuff is super flexible. It focuses on native end user experience. The rendering is like really fast. At least from the limited use that I've done, the rendering has been awesome. Basically what Flutter does is it runs on its own engine, and it just like writes to the canvas, kind of like how a game would, like on your mobile phone. It's super cool the way that they do it, and really easy to use. Currently they have full iOS and Android support, and it just moved out of beta, native desktop support. And just now, I mean like, I'm talking like a week ago, they came out of beta into full web support. And so they are now on every single platform. Currently the web portion is actually a fork of Flutter. So they say it's one code base, but if you were writing a web app, you actually would have to have a second repository and then have different imports. It'd be the same code except different imports, if that makes sense. There's some nuances there that I don't really understand. I didn't have time to get into, but to my understanding there's that small piece. But it supports everything on the web, from even progressive web apps as well. So you can actually build one code base and actually install your Flutter application in the same way that you would install a progressive web app, which is kind of cool. So yeah, Flutter code is compiled out of ARM machine code using Dart's native compilers, so the Dart language was built by Google for Flutter, which is why I believe that the developer experience is so easy and kind of fun to use, because it's a language that's built specifically for a technology, and there's a lot of cool integrations there. And from my experience, it hasn't been very buggy at all. It's been really easy to use. So this is an example of just a Flutter application right here. Not very much code, which produces this right here. And we'll get into how everything looks the same and why it's so cool. So I'm just going to run this here. If you can see that. If it goes. There it is. So real quickly, one thing that a lot of devs love about this is this instant run or functionality that after you build it the first time and you update something, you can just press the lightning bolt in Visual Studio Code or IntelliJ, and it like auto refreshes and auto updates. They call it hot reloading. It's really cool to use and really fast, and I love. So for example, here's just a Flutter application. This is iOS, and then you can, like, I'll change text here, and then press this, and you can see our text is already changed there. That's really new to like native mobile development. And from Android experience, Android has tried this, and it doesn't always work super well. And Flutter, I believe, has nailed it here, which is kind of cool. And then just real quick, showing how integrated it is with things like Android, or I'll say IntelliJ, or VS Code, is you just kind of select your new target device, and then it'll build it on that new device. And then I'll put them side by side here to show you there's like no differences here between your applications, except for the subtle OS level stuff. which like you'll see at the top here. Real fast, as I close here on time. There it is. Yeah, so as you can see, it's the same application. There are two things. They're either Cupertino widgets or material widgets. So you can either build it's like iOS-ish applications or material applications, which is Googleified. But the nice thing is as you do that, especially in the material side of things, it looks pretty standard for web as well, which is kind of cool. In regards to adoption from other companies, where is that? I had it up here. So as you can see already, as I'm clicking through here, these are all a bunch of articles by people that have been using Flutter, and it's just I was so surprised to see all the support out there, countless hours of tutorials and videos and developers that are starting to call themselves sole Flutter developers. I was listening to this podcast today, and he was saying no, I'm a Flutter dev, that's what I do. And a lot of companies are starting to adopt it. Where is this? It's here, I promise. It's a list of companies that have done it. Yeah, I don't know where it is. Here we go. Android apps built by Flutter. Oh, the showcase. There you go. So yeah, if you want to go check out some Flutter apps real fast, Realtor.com, the New York Times. When this article was written, their Kin puzzle was built on Flutter, but now since then they're getting ready to roll out the whole New York Times app in Flutter, and then a lot of Square stuff. If you have that little Square reader, that's all Flutter now. And then the Google Assistant, you can write apps in Flutter for the Google Assistant, and in 2020, summer 2020, the entire Google Assistant will be written in Flutter. So in regards to adoption, I don't know, I'd move it from the trial category, but that's just my opinion. That's all I got. Yes, Sam. I did not, Sam. If it runs Android, it will work. That's what they say. Yeah. Yep. There's little things that you can do in there, you still have the ability to say if device, whatever, do this thing or show this UI, but they've done some cool things with their widgets that will also auto-recognize what device it's on and build a layout based on that. And so that's a lot of Dart level stuff, which is another example of why Dart is so great for this specifically, is because a lot of that's already built into the language itself. Builds the same one, but it's all in the App Store. It's the same app in iOS anyway. It's not done any differently, if that makes sense.
I've never worn one of these before. Is it on? Can you hear me? Awesome. Okay, so I had pipelines for infrastructure as code, and this is a technique, and I'm going to keep it really boring. I have nothing to show, so I'm just going to talk. What is it? It's exactly what it sounds like. It is applying pipelines to infrastructure as code. Infrastructure as code, as a code overview, empowers developers to create the scripts to deploy the environments consistently and reliably. Pipelines is used with code to create a build process that allows you to automate. When a new commit is pushed, it will grab it, build it, test it, and put it on the server that's needed. And when you put these together, it allows for the automation of deploying parameterized environments for the code to run on in a consistent and version-controlled setting. There are typically 3 parts involved. There is a source repository used to keep track of the config files that you'll be using. Then there's an artifact repository, which is what holds the images that you will be deploying. And then there is a CI/CD tool to run the pipelines. ThoughtWorks suggests 2 tools in particular to use with this process. The first tool is Packer, and this is a tool that allows you to create an image, a parameterized image of the environment that Packer is installed on. And then the second tool is Terraform, which both is the scripting language to leverage the tool as well as the tool that is actually used with the Packer images, as in this example, to deploy the environments. Why should I care? So this is kind of the next step in enabling developers to do more, control more, without having to have additional team members and additional teams in general to support the applications that are being developed. This allows automated testing on the environment itself to more quickly detect issues that arise in changes to the scripts. With the maintenance of an artifact repo, it allows quick rollbacks of the environment in case something changes that breaks the application. Feeds it directly into existing pipelines and processes in the development life cycle, so ease of use. Everything kind of can become a very, very good process, all automated and consistent. The technique also allows self-documentation and versioning of scripts itself used to create the environments, but also the process by which the environments are configured and tested. And lastly, some restrictions and potential concerns. The simplest one is the client's team structure may not allow for this. They may have their own infrastructure team, infrastructure process, and so if that's rigid and in place, you're not going to be able to use pipelines for infrastructure as code. But secondly, just using the pipelines and getting used to some of the tools and techniques around it takes time and thusly money for clients and the project itself. And that's it. Absolutely not.